Hi folks, Mr. Long here. We're going to do a screencast today, I am going to do a screencast today. Limits at point, limits that cause point discontinuities, and look at simplifying them. We're going to look at fraction sums and complex fractions. Remember, the whole idea here is that we're looking at scenarios like this, where you have a function that comes along, and then maybe due to, so if this was x equals 3, then I'd have to have x minus 3 over x minus 3 somewhere in the fraction, right? Because then that divides out and I can remove it. That's why they call point discontinuity also a removable discontinuity. Okay, so we're looking for holes in the graph. So here's our example right there. Okay. And so with this one, why it doesn't go in with the simple fractions is because it's a fraction sum or difference, right? Because we're adding and subtracting here. If you looked at this, right, because you always want to sub in the value to see if you've got a point discontinuity. If you subbed in negative 2 there, well, you'd get 0 on the bottom. If you subbed in negative 2 for that x, you'd also get 0 on the bottom, right? So you'd have 5 over 0 minus 5 over 0. Now, that might be, right, like we would normally look at it and go, well, it must be a vertical asymptote because we learned before that a number divided by 0 is a vertical asymptote. But we can't know that for sure because we've got this darn subtraction or in other cases addition there. So what we need to do is to simplify fully, okay? Simplify it fully first into a single fraction. So how do we go about doing that? Well, we have to get a common denominator. And you can see right here, so I see an x plus 2 here and x plus 3 here. Now, I could have had it as x squared plus 5x plus 6 first, right? In which case you would have had to factor it and you would have gotten x plus 2, x plus 3. So anyway, there's our common denominator. I already have the common denominator for this part of the fraction. So what do I need to do to this part of the fraction? Well, I want to make it look like x plus 2 times x plus 3, which means I'm going to multiply by x plus 3 divided by x plus 3. Now, what am I actually multiplying by then? Yeah, 1, right? So I'm actually multiplying by 1. So now I've got a common denominator, and I can expand through the brackets eventually, right? So now I've got a common denominator. So if we look at this, I'm going to have 5 multiplied by x plus 3 minus that 5. So what we do is we come down here to the next line, and I've just written it into a single fraction now, because I know I have a common denominator right there. Notice this sign, the limit signs carry down as you go. Now, I am missing equal signs. You have to have an equal sign each step of the way. And you don't remove the limit sign until you substitute the numbers in at the end, and then it's no longer a limit. Okay, so now I'm just going to have to expand through the brackets and simplify, right? So I expand through those brackets, I would get 5x plus 3 times 5 is 15 minus 5, right? Well, then I simplify again here, or rather I simplify after expanding. If I simplify that, 15 minus 5 is 10, that 10 there. I'm always looking to common factor. Always, always, right? So if I look at this, I've got 5x plus 10. The common factor there is 5, right? So now I common factor out the 5. 5 bracket x plus 2. Well, look at that. X plus 2 divides out with x plus 2, and I'm left with 5 divided by x plus 3. Now, when these divide out to 1, how does that change this fraction fundamentally? Right? You can see now why negative 2 was such a problem, right? Negative 2 plus 2 is 0. Negative 2 here plus 2 is 0. So I've got 0 over 0, right? 0 over 0. So what we're doing here is we remove the factors causing 0 over 0. Okay, we remove those factors. All right, so then, because they divide out to 1. And now this is the last time I'll write the limit statement, because after this, I don't have to, it doesn't have to be a limit anymore, right? Why doesn't it have to be a limit anymore? Here's why. I could only get close to -2 before, because if I got right to -2, I get 0 over 0. So now I can lift the limit. I don't need to limit myself to getting close to -2. I can actually go right to -2 now, because I don't have 0 over 0. So I have removed the 0 over 0, which means instead of getting close to -2, I can actually get all the way to -2, and I can remove the limit. Okay, so that becomes -2 right there. It is, x is replaced by -2. -2 plus 3 is 1. And then I have 5 divided by 1. This works out to 1, right? Which is 5. So our limit is 5. So I've got some sort of a graph like this. And at x equals -2, the y value is 5. Okay? In other words, the point discontinuity is at a value of x is -2 and y is 5. Okay, there's a hole there. Okay? So, you may want to go back over that. I went through that fairly quickly, but and I just sort of annotated the parts to prompt you to go through those steps. So you will have a copy of this like as a blank without any writing on it. So if you want to go through yourself and actually add in the writing, you can do that. That's probably a good idea to try this on your own after you've looked at this video, to make sure you understand each step. Okay, folks. So again, pause, rewind, go back over it, but I think you'll understand the process. Okay, and that's how you do a limit for a fraction sum or difference.